All right, listen up. This is geometry, trigonomic ratios. We're going to go through and actually learn some trigonometry.
Oh my god.
Thank you. Thank you for letting me have my own notebook back.
No, you're not welcome. I don't like it.
If you really wanted it, you could have just taken it.
I don't know. You're actually kind of scary. I didn't really want to, like.
I'm going to come steal the tape from someone.
Okay.
It's
Yeah.
right here. Oh my god.
4, 5.
I'm stealing them both.
Right, 6 and 7's not in here. Oh, it's right here. No, it's right here. I see it.
Oh,
I did tape it in. Okay, so let's take a look at this. So the other day in class, we are going through and we are identifying my sides of the triangle, right?
Yeah.
So we always have to start from,
I was gonna say given, but
it's a given angle.
given angle.
The given angle, yes, that's very good. So the given angle is my start. So now, in these ones right here, what is going to be my given angle? Not 90.
94.
Nope, try again.
Hypotenuse.
Yup.
Hypotenuse.
Center. The center.
I heard it. Say it again over there. Theta. Who said theta?
me.
There we go. So we got theta over here. You ready?
Catch it, catch it, catch it, catch it. Oh, damn.
You don't got these hands.
Okay. So theta. Theta on this one is where we're starting out. So theta is a Greek letter that we're starting, and it signifies my variable of my angle, right? It's kind of like x, but when we're talking about angles, it's going to be theta. So let's take a look. So from here we have sine, which is going to be, okay, for this one right here, it is sine is going to be opposite over hypotenuse. Okay, opposite over hypotenuse. So from this one right here, so here's my reference angle. Which one's going to be opposite of this one?
BC.
BC, very good. So I'm going to put an O over here, right? And my hypotenuse is going to be what?
AB.
AB. So it's going to be sine AB, right? So I'm going to put an H right there. Sine is going to be opposite over hypotenuse. So it would be whatever this value is over this value. Yes?
Yeah.
Very good. This next one is cosine. Hey, you people. Quit laughing. You're having too much fun. Stop. Okay. Cosine is going to be adjacent over hypotenuse. So adjacent over hypotenuse. So now from my theta, which one's going to be adjacent on this one? DF. So we have, I'm going to put an A right there. Hypotenuse is DE, right? Very good. This last one is going to be tangent. Tangent is opposite over adjacent. So from my angle, so opposite would be MN. So put it over there. Adjacent is LN. Very good. Now, you guys ready for this? Okay. Y'all probably ain't ready for this. Okay. So this is actually called. Did you really do that? No. Stop. No, it's not Space Jam. All right. Now, for what we're doing here, I'm going to teach you guys a mnemonic. A mnemonic is a phrase, a rhythm. It is a way that you can actually figure out and remember stuff all the time because, okay, it is a phrase that you remember. So, you guys ready? So we're going to, yeah. A lot of times, usually you're doing this and it's going to be SOHCAHTOA. That is one way. You guys have done this before, SOHCAHTOA. And there's another way, which I think everyone remembers a little bit better. Okay, you ready for this? Okay, some old hippie caught another hippie
Talking.
tripping on acid. Okay, so you guys ready? Okay, so repeat after me. So, some old hippie caught another hippie, tripping on acid. That is the easiest way over the amount of years I've been teaching this. Eh,
Did you make that up?
No, I actually got it from another teacher.
Right now. Like how you teach.
Huh?
Just let go.
Anyway, all right. So this is actually the easiest way to memorize this ever. Okay, the SOHCAHTOA, yes, it's great. You remember, but it's trying to remember what letters go where. If you remember the phrase, okay, I'm pretty sure most of you guys can already remember that phrase. Okay, some old hippie caught another hippie tripping on acid. So it's always going to be like that. Okay? So for us to be able to do this, let's go ahead and set this up. So we're going to find this out. So for this one right here, the Greek letter alpha is this one over here. It's going to be, this is the alpha, this one's a theta. Remember, we use Greek letters when we're talking about angles. Theta? Mm-hmm. All right. So from theta here, so these are all theta, right? So sine. What is sine? Opposite over hypotenuse, right? Okay. Opposite over hypotenuse. So another way to actually rewrite this whole thing is if you write it, it's SOHCAHTOA. There it is again. So some old hippie caught another hippie tripping on acid.
Track.
Yep. Pay attention. All right. So sine. So sine from here. So what is opposite theta? 3. What is hypotenuse of theta, of this one?
5.
So my answer is 3 over 5. Now, let's look at tangent. Tangent is opposite over adjacent. So from theta, opposite is 3. Adjacent is? Say 4. Yeah.
So 3 over 4.
Mm-hmm. Cosine. From theta, cosine. Cosine is adjacent over hypotenuse. So adjacent is? Hypotenuse is? This is getting pretty easy now? Okay. All right, so now we're going from alpha. So we're changing our reference angle. So we're starting at alpha now. So cosine is adjacent over hypotenuse. So from alpha, what is adjacent to alpha?
15.
We're over here. We're still on this one right here. We're doing this one. What is adjacent to alpha? 3. It's going to be 3. 3 and hypotenuse is 5. So this is 3 over 5. Now tangent of alpha. Tangent is opposite over adjacent. So opposite is?
4.
Adjacent is?
3.
Very good. Sine of alpha. Sine is opposite over hypotenuse. So opposite is? 4 over?
5.
Very good. Is that easy? Okay, let's keep going on this now. Now we're actually going at this from alpha again. I'm sorry, theta again. So here's theta here. Sine, opposite over hypotenuse. So opposite is? 15. Hypotenuse is? Very good. Does anyone have any questions of what we're doing here? This is pretty basic for what we're doing. We're just identifying sides now. Questions, concerns, complaints? Okay. All right, so from theta, tangent is going to be? Tangent is?
15.
Opposite over adjacent, so it's going to be?
15.
Over?
8.
8. This is 8 right here. So it's 15 over 8. Now here's theta. Cosine is adjacent over hypotenuse. So what is adjacent to theta?
8.
Over 8 over 17. Now let's look at it from alpha. We're looking at it from this side now. So what is cosine from alpha? Cosine is adjacent over hypotenuse. What is adjacent? 15. Adjacent's 15. Hypotenuse is 17. 15 over 17. Tangent of alpha. Tangent is opposite over adjacent. What is opposite of alpha?
8.
What is adjacent?
15.
So 8 over 15. Now sine. Sine is opposite over hypotenuse. So what is opposite of alpha?
8.
Hypotenuse is?
17.
Very good. What do you notice about sine and cosines that we found? They're the same, right? They are the same. Okay? Because when I change angles, the opposite changes, doesn't it? So opposite changes. So when I change the angles, right here, do you think this will be true for any right triangle? Say yes.
Yes.
And, okay, we change the reference angle. Each time. And that leads us to this next part right here. All right, trigonometric ratios of complementary angles. Class, what is complementary? I heard it.
Similar.
90 degrees. Who said 90 degrees over here? Right there? No, I didn't hear from you. So, let's try this again. Class,
Yes.
what's complementary? 90 degrees. 90 degrees. It's going to be 90 degrees, so that means that the two angles add up to 90 degrees. So, if A and B are acute angles in a right triangle, kind of like I have here, okay, sine A is equal to cosine B, kind of like what we did here. Sine theta is equal to cosine alpha, okay, and cosine alpha is equal to sine of beta. Therefore, if theta is a measure of an acute angle, what does acute mean? Less than 90, very good, less than 90. Then sine theta is equal to cosine of 90 minus theta. All right, so now, think about this mentally. I want you guys to think about this. So I'm putting my pen right here on B. If I tell you that one right there is going to be 50, what is the other one going to be? 40. Why 40?
90 degrees.
Because they both together add up to 90, right? Okay, if I tell you that B is 60, what does A have to be?
30.
30, because they both have to add up to?
90.
Okay, very good. So if I tell you that B is 45, what is A?
45.
90, 55.
45.
Oh,
45 gives you 90, right? Now, isn't that the same thing? If I were to take this value, which I said was 45, right? So if I put it there and say, hey, 90 minus 45 gives me
45.
45. So when I said this one right here is 50, okay, 90 minus 50 gives me 40. That's what's left over. That's how I get that. So if theta is 30, then 90 minus 30 is
60.
okay. So let's see. Now, for this one right here, so sine of 30, put in your calculator, give me 2 decimal points, please. Calculator, 2 decimal points.
To what?
2 decimal points.
0.5.
Negative 0.5.
Dude, where's this candy?
0.5, right? Who's Candy? Is he on a roll?
What?
I think so.
He thinks so? I can't hear him.
He's racist.
Okay. Oh, here. Good job. All right. So, what was my other angle? If this angle's 30, this angle here is, say 60.
60.
Very good. 60. Now, this I want you guys to do. What's cosine of 60? Cosine of 60. Plug it in your calculator right now. Don't just stare at me awkwardly.
Wait, Mr. Bushra.
You.
Mr. Bushra.
0.5.
Yes, you. Right there.
Mr. Bushra.
Pick up the calculator. Yes. Huh? 0.5. Pick up the calculator. Push the button that says trig.
Says 0.5.
What is it?
Pressing them.
Let's see. So,
0.5.
trig cosine 60 degrees. Ah,
How do you do the degree? Just
the pi button. Go push the pi button and it's there. And it comes up with 0.5.
Wow.
Hey, look, they're the same. Now, what is cosine 30? 0.86?
He's smart.
Or he just read ahead? Or someone actually pays attention?
I pay attention.
Well, I said it before. I definitely said before. Nobody listened to me.
I'm sorry, did you say something?
Yes, I said 80, or we're rounding 87.
0.87? 0.87?
187.
Okay.
I said something.
Did Genesis say it?
No,
Yes.
she's
Yeah, she did give her candy.
She did?
Miss Pancho, give her some candy. Really great teacher.
I can't. Can't do the candy.
I can't see.
Here, boy.
Do you have any candy?
Wait.
There you go. So, what do you think the sine of 60 is going to be? 0.87, right? All right, so
It's the same thing.
yeah, it's going to be the same thing. All right, so let's take a look at this problems we got working on today. Okay. Says three sides of a triangle referred to as hypotenuse, adjacent, opposite. Label each side of the triangle using W as the reference angle. If W is the reference angle, this side over here is?
W.
Try again.
Adjacent?
Opposite. This side over here is?
Hypotenuse.
Down here?
Adjacent.
Is that pretty easy, right?
Yeah.
Do the same thing now. This time use the theta as your reference angle. Okay? Now, you guys are going to do the same thing, but now instead of giving you Greek letters, I'm telling you what angle it is. So, sine of 50. Sine of 50. We know sine is what over what? Sine is opposite over hypotenuse. So opposite is 12. Hypotenuse is
16.
Is this pretty easy now?
Yeah.
Okay. Everything that we did just now on the notes, the same thing we're doing here. Okay, don't forget, like, subscribe, hit that notification button.
Like and subscribe.
Dude, you need to tell me to